Hello everybody! It's been a couple of weeks since I've made a video and I wanted to bring you up to speed on what I've been doing for my head reader rig. Alright, so as I mentioned, it's been a couple of weeks. I've been working hard. I was hopeful that I would post videos along the way, but it seemed I kept running into roadblocks and design issues. So I've just been working away on this thing for the last couple of weeks, so wanted to bring you sort of a little update on how far I've gotten. So if you remember in a previous video, I talked about some of the problems I was having about the power, specifically the power, the voltage regulators, and how I was running it off of two power supplies. So I had the battery to run the actual reader itself, and then I had a AC/DC converter to run like the Arduino and things. So what I ended up doing is I got just a standard battery pack for like a cordless drill, and it's 19 volts. Seems to be doing the trick. I found it difficult to find a 24 volt battery in this current configuration, so I'm still looking for the ultimate solution. But what I've ended up doing is, let's see if I can get this in here a little bit better. Basically what we got is I've got the Arduino, still got the switch to open up the door, and now I've added this little board in here, and I know it's difficult to see, but basically it's like a little power junction box. So what I've got is I've got the battery pack coming in, so everything on this side, these two leads over here, you get the power and negative for everything that's 19 volts, and then a step down to 12 volts in the middle, and then 6 volts on the end. And what I ended up doing is moving the voltage regulators down to underneath the door here. So they're kind of situated under there on a little piece of plastic and sort of all wired together. You might also notice that the back of it has gotten nice and shiny. What I ended up doing here is I added an aluminum shield, aluminum not being the best material. I think copper or something like that. I know they actually do make special metals as well to reflect these type of signals. Specifically, I'm looking at the 125 kilohertz range, right? So I can block the RFID reader and the noise from the reader. But so basically what I had, just because I had it on hand, is just a thin piece of plastic, and I coated the other side with 2 layers of aluminum foil tape, and I went vertically and horizontally. And then, of course, I flipped it around and screwed it to the board, so that way I could mount the Arduino and all the other electronics to the back of it, because obviously I don't want to short them out. And I did the exact same thing down here. So I know it's very difficult to see, but the top of this little cavern underneath the door is aluminum foiled, and then the little plastic plate that these guys are glued to, the same trick here, where I put it on the bottom and then flipped it upside down. So that seems to be working. It's not the best, I know, but it's what I had around and works pretty well. So now I get fairly decent read distance. Obviously I couldn't really measure it very precisely. It was sort of more anecdotal, just kind of scanning my hand or scanning a random card, but it seems to be working. So I got that done, happy with that. And then I moved on to finding a way that I could measure the different distances, right? So that's kind of one of my goals here, is I want to be able to find a mechanism that I can move in and out very gracefully and accurately to figure out when the card reader would be detected. So obviously, this being a standard head reader, I plan on sort of doing other tests with different types of antennas and things as well. But this is sort of the starting point. So what I came up with is a little sled mabob here. Let me switch to the overhead camera. It's a little bit easier to see with Mr. Battery out of the way. And then, so what I've got is not very beautiful looking, but again, prototype, work in progress. So wooden base, very simple. And then I used 2 linear bearings along the sides, and oops, out of frame. Standard stepper motor over here, and I just had a bearing and some washers laying around, so I rigged it up over here as a pulley system. Made a block to screw to the plate itself, and now when the motor turns, you know, slide the sled forward and backwards. And I designed it. I went through many iterations with this. I think even though that this is still my prototype, I think this is probably the third or fourth time I've rebuilt this. Pretty much everything I've rebuilt, various components along the way throughout the last couple of weeks, and it's getting better. The first big challenge I had, this is the first time I've worked with linear bearings. I don't know if anyone else has used linear bearings in the past, but I found it very interesting how accurate it needed to be. So what I ended up doing is I actually 3D printed a jig to figure out where these screw holes needed to be. So that was a whole couple of days of learning and tinkering to make sure that, you know, I accounted for the shrinkage and everything else, and got them in the exact right spot so I could just plop a jig on this piece of plastic and then drill it. Luckily, I do have a milling machine, so I could be very precise with where I could screw them in. So that worked out really well. I was happy with that. And then my next big issue was the motor mount. So the motor mount actually ended up being 3D printed as well. A couple of different parts here. Again, lots of different iterations on getting this thing set up. But what I did is I just used CAD to draw up some 3D plans and kind of glue them together. I think the next version I make, or the final version, I'm kind of redesigning this, and it'll be all one solid unit. It doesn't really wiggle right now, but I'm concerned that the epoxy isn't holding it quite as strong as I want it to be. So hopefully that'll go away. I also have plans to redesign this. I've been looking online, trying to figure out how to do like the belt tightening for like 3D printers and things. The biggest problem I see is a lot of the belt tighteners are when the belt is flat, and my belt in this configuration needs to be vertical. So I'm kind of drawing up my own that will fit my criteria on what I need here. And then of course have the holes so I can mount it to the board. I'm also finding this to be a bit clunky, the actual bearing assembly. It works. Again, it's a proof of concept. It, you know, gets the job done, but it's not very elegant looking. So right now I sort of designed it so it's big enough to hold a hand, and then, you know, move that hand into the path of the reader. So hopefully very soon, hoping this weekend, I'll get a chance to sort of finalize a bunch of my kind of playing around here, and develop sort of the finished plans, if you will, on how I'm going to build this sled. I'm still not 100% sure this is going to be my ultimate solution, but it's sort of what was in my head as far as how I can get my hand to move into the field. And then my thought process is I'm going to have the same Arduino that controls the reader control the motor. So what will happen is, as the hand moves into the field, as soon as it detects a read, it will stop. And then I'll be able to calculate out, you know, the distance from the reader. So I need to basically build in sort of a zeroing mechanism. So this will come up and, you know, touch the reader and say, okay, this edge is 0, and zero itself out. I also plan on adding some gradations to the sled itself. So, you know, 1 millimeter, 2 millimeters, etc. So that way I can correctly figure out exactly how far in it is. So that's where I am right now. I hope you enjoy these updates. Try to post them regularly, but you know, like I said, I've just been cranking away at this thing, and I really wanted to get it done. And every time I thought I had it done, I found another problem that I needed to figure out. So, but it's been a fun process, been iterative process. I'm certainly not an engineer by trade, so this is sort of new for me. I mean, I like building things and tinkering around, but this is not my my forte. So it's kind of funny. I'm sure engineers out there will be looking at this and thinking, that's the wrong way to do it, which you're probably right. So yeah, if you got any other ideas on how I can correctly measure or more accurately measure distance, because that's kind of what I'm going for at this moment, is trying to figure out how far away you need to be able to read an RFID tag. Ultimately, the implantable ones, right? That's what we're talking about here. But starting small, starting simple, and trying to get the just the handheld, HID cards. Try those as well. So that's what I have for today. I hope you enjoy these updates. Let me know what you think in the comments, and I will be talking to you soon. Thanks for watching.
So, Michael, what can people do if they liked this video?
It would be nice if they would subscribe, click the button, and leave a comment.
That would be cool.
That would be neat.
Would we ignore them?
No, I try to get back to everybody.
Okay.
Yeah.